Hello everyone, welcome to the video lecture series of C programming language. We are in our lecture number 60. In this lecture, let us learn about dynamic memory allocation functions. So what actually these dynamic memory allocation functions are and what is the use of these dynamic memory allocation functions? Let us see. Okay, so before going to learn about this dynamic memory allocation, normally whenever we want to store more than one value, then we have jumped to a concept of arrays. So using arrays, we can store more than one element. But what is the problem is, at the time of declaration of an array itself, we need to tell like the specified memory, whatever we want to allocate. Are you understanding? So whatever memory we want to allocate, that has to be done that has to be told at the compile time itself. So with that, what happens is sometimes it leads to the wastage of the memory space, or else if sufficient amount of memory is not there, it will lead to program failure also. What do you mean by that one? Suppose if you have allocated an array of 100 elements and you have used only 10, you have stored only 10 values. That means remaining 90 locations, whatever you have allocated, that are totally waste. And also if you have allocated sometimes 10 as you have given the size, but you want to you want to store 20, in that case it will lead to a program failure. Got it? So with the mismatch of this memory requirement, sometimes there may be a waste of memory or sometimes there may be a program failure. To avoid this problem, we need to go to a concept called dynamic memory allocation function. Now, what is the use of this dynamic memory allocation is using these functions, whatever we are going to learn, we will be allocating only required space at the time of executing your program. That means we are not writing anything in the program that this much memory we want to allocate, but at the time of executing our program only, we will be allocating the sufficient amount of memory. So because of this, what happens is no wastage of memory will be there. Got it? So memory will be required, that memory space required, that can be specified at the time of execution by using your dynamic memory allocation. And once you have allocated and if your work is done, you can free that memory also for the other purpose. So that allocating and freeing of the memory can be done dynamically at the time of runtime by routines, which are called as dynamic memory allocation. The basic idea behind this one is the amount of data cannot be predicted. Normally, whenever in a day-to-day basis, we can't predict the amount of time beforehand, and the data input whatever we want to give, that keeps on changing, isn't it or not? So to solve that problem, we can effectively manage our memory by using these dynamic memory management techniques. Normally the memory allocation process in C programming language, if you see, if this is the complete memory, then the program instructions, whatever instructions you write, that one, and the global variables that you are declaring in your program will be stored in the permanent storage area. Right? And then the local variables, whatever you write within the function, that will be stored in the stack. And the space between these local variables and this permanent storage area is called as a free memory, and that can be used by your dynamic memory allocation functions. And normally this free space is called as heap, and this heap goes, sometimes it increases or it reduces depending upon the number of local variables and global variables and instructions you have in your program. So the size of the heap is not constant, it keeps changing. So this is the total memory allocation once you write your program in the C. Right? Now this is the space that will be used your dynamic memory allocation. Right, all of you? Now if you see, we have 4 types of memory allocation functions. All are functions: malloc, calloc, free and realloc. All are these functions, and these functions are defined in our header files. Now malloc, what is the use of this malloc is, it is used to allocate required amount of one block of memory. And how that can be done, we'll see in the future slides, but this will be allocating a block of memory, required block of memory. And calloc is used to allocate multiple blocks of memory. And free will be freeing the space that has been allocated by malloc and calloc, and realloc is used to modify the space that has been previously allocated by using malloc and calloc. By using malloc and callocate, you have allocated some space, but if you want to increase the size, let us consider, then in that case you can go with the realloc. Okay, so these are the four memory allocation functions we have, and these are called as dynamic memory allocation functions. So let us learn one by one. So let us start with the first one, that is allocation of block of memory using malloc. Now what is the use of this one is, it is used, this function is used to allocate single block of requested memory. Single block is nothing but like array, if you want to store array values, if you want to store, then single block of memory can be allocated. And whenever you are using this malloc, the amount of request memory is allocated, and it returns the pointer of the first location, and that pointer is of always, by default it is void. Okay, and all the memory locations, whatever memory locations you have allocated, let us consider you have allocated like this, and all these locations will be having an initial value of 0. So like this, the value initial value will be not 0, it is a garbage value. Garbage value will be stored initially, right? Now if the sufficient amount of memory is there, then it will be allocating that much of required requested memory. But if that much of requested memory is not available in our memory, then it will return the null value. Okay, now the general format to allocate the memory is, we need to use this one. You always, I told you, malloc function is used, and you need to specify the byte size here. That many number of bytes will be allocated, and that means that many number of bytes will be allocated. Now after allocating the byte, the starting address will be stored in a pointer called, like any pointer, let us consider p, and that p will be always of data type void. Now if you want to store the address of integer, then you need to typecast this one into that data type int. So that can be done by using this typecast. So always this is the format you need to use. PTR, that is the pointer with which you want to store, and then typecast into the required data type, int, float, like that. Use the function malloc and specify size byte. So the example you can see here, I am writing p equal to int star malloc 100 into size of int. If you are writing like this, then what happens? What is the size of int? It is 2 bytes. Then the memory space equivalent to 100 times the size of int, that many number of bytes will be reserved. So the address of the first byte will be allocated to the p, and always this p, if p should be of int data type. That means we need to write int star p in our program. If you are not writing like this, and if you are typecasting like this, it will throw an error. Okay, so what happens? So this much of 200 bytes of space will be allocated, because we have written 100 into size of int. If you are not writing 100, only 2 bytes will be allocated, right? And then the starting address will be stored in a pointer p. Got it? So this is how malloc will be done, and if the malloc, if that much of space is available, then only continuous memory space will be allocated. If the memory space is available and if it is not continuous, then it will fail in allocating that memory, and it will return a value of null. Always remember, whatever space you are allocating here, that is of continuous space. In your memory, if you have 4 bytes of memory space here, and after this again 4 bytes somewhere else, if you have like that also, it will not allocate. In that case also, it will return a null value. So whenever the pointer is storing a null value, we can understand like the malloc function is not able to allocate the requested memory. So to understand this one, you can take one program. Header files are declared in the main function. 2 variables are declared, and a pointer variable height is taken. Now we want to find out the average of the elements that are stored in that one. So we want to store how many values, that you will be asked at the runtime. That value is n. Now to this pointer, we are using malloc function, and n times size of float, whatever we have, that will be allocated. That means if you want to store 5 values, then you need to give n value at the time of running your program 5, and 5 star 4 bytes of float. Understood all of you? Normally, if you are not using this one, what happens? Then you need to write height of you need to write height of 5 at the time of in the program itself, which is called as runtime and it is fixed, which is called as compile time and it is fixed. So we can't change this size. So instead of going like this, we are using we are storing the array elements using malloc, and the number of elements you want to store will be given at the time of running your program, which is stored in n, and depending upon the n value, that much of memory will be allocated. Now once this is allocated, what we are once the memory is allocated, we are asking to the user to enter the input heights of all the students, and all the student heights values will be allocated like this. You can write like this. We already know this approach. Okay, pointers and arrays concept we already learned. We know why we are writing like this, because suppose if you are allocating 5 bytes like this, then the starting address will be stored in height, isn't it or not? And height ampersand of h of 0 will be representing to this one, ampersand of h of 1 will be representing to this one. You can write like this, or else you can write height plus I also you can write. We already learned this one. I will be linking in the above I button. You can go through that lecture once if you have any doubts. Okay, now we are accessing all the values, and after accessing all the values, we are performing the sum of sum of all the values, and finally we are finding the average sum, and we are displaying this one. Got it all of you? Here you need to concentrate here. You can write like this, or else in the next example I will be showing you. This is the expected output of our program. It is asking us to enter the number of students. I have given 5, and 5 values will be read, and we got the average. You can read the values like this, or in the next program I will be showing you. I am in start PTR, and I am asking enter the number of elements you want to read, and number of n into size of int. That means 5, if you give 5 into 2 bytes of memory will be allocated, and it will be pointed by the p. And if you want to read, if p equal to null means what do you mean by that one? That much of memory can't be allocated. In that case, PTR value will be null. So if PTR will be null, I am saying like sorry, unable to allocate that memory, and I am exiting from this program. Else, what do you mean by this one? If it is not entering here, what do you mean by this one? PTR is not null. Memory has been allocated, and we are asking the user to enter the array elements. So how we are accepting the array elements? This also I already told you. We can read like this, or else you can write ampersand of PTR of, oh my god, my handwriting, ampersand of PTR of, you can write, sorry, not this one, I will erase. What you can do, ampersand of PTR of I. You can also write like this, or else you can write like this. Both are same, and we are performing the sum of all the elements in the array, and sum is displayed. So the output for this one is, it is asking the number of elements in the array, and I am giving 10, 10, 10, and I am getting the sum 30. Okay, so this is the program to find the sum of all elements in the array. You have already done this one without using the pointers, but here we have done using the pointers and dynamic memory allocation function. Got it? This is the use of malloc. Okay, make a note of this this one, how we have allocated the memory at runtime using malloc function. Next one is calloc. The main difference between the malloc and calloc is malloc will allocate only one block of specified number of bytes. Okay, but whereas calloc will allocate multiple blocks of requested memory. The main difference between this one is in the earlier case we used to write size of int, like we can write 100 into or else if you don't write 100 also, 100 into size of int. If you write 100 into 2, that is 200 bytes of memory will be allocated. That is considered as 1 byte only, 1 block only. But if you want that blocks, multiple blocks, then you can go with calloc, where you need to specify the number of blocks of that size. Got it? So this number is missing, it is not there in our malloc. Now we need to specify the number of blocks of this size you need to mention. And one more difference between malloc and calloc is, in malloc the initial values will be garbage values, but whereas if you are using calloc, you will be having a 0 value in your memory. And like malloc, it will also return null if that much of memory, continuous memory, is not available. Right? So this is about calloc, and the way you have used it for malloc, similarly you can use for calloc. Only the number of blocks are missing. With malloc only one block, with calloc multiple blocks. That is the difference. Okay, and once the memory has been allocated, and if your work is done, and if you don't want to use the data in future, no longer the data is used, then we need to release that data. We need to remove the data from the memory so that that memory can be used by others for other purpose. If you are not if you are not releasing the data, that memory will be consumed until the program exit. Are you understanding? So if you are allocating using Malloc and calloc, if you are allocating memory, then it is our responsibility to free the memory. Then how can we do that one? By using a function called free. The normal syntax will be like this: free, and make use of the pointer whichever you are using in your program. Okay, so to understand this, I'll show you one program. This is the earlier program which I have discussed, where we are finding the sum of all elements in the array, and this statement is used to allocate that much of memory, isn't it or not? Okay, so after allocating the memory, we have stored the values, and we have found the sum of all the values. Now once your work is done, it is our responsibility to free the memory. To use that one, we need to use a function called free, and you need to write the pointer. What is the pointer we are using? PTR. And once you write like this, then what happens? After performing your operation, all the data that has been stored in that memory will be freed, and that memory location can be used for future purpose also. So make a note of this one, all of you. Free PTR is used to free that memory that is allocated by using Malloc and calloc. Okay, and the last memory allocation function is your realloc. This is used to alter the size of the block that has been allocated by Malloc or calloc. Sometimes what happens is, once you have allocated by using Malloc, we want to alter the size of the memory that has been allocated, because more memory might have been allocated, or the memory that has been allocated is not sufficient also. So sometimes we want to reduce the size, sometimes you want to increase the size. Then in such a case, we can use this realloc function to alter the size of already existing memory block. So how it can be done? Simply you need to use the function called, suppose if you have allocated by using Malloc, then you can write a statement called realloc, make a point, tell like for this pointer only, the new size is this one, not this size. So from this statement onwards, the new size will be allocated for this PTR, and again we need to store in this PTR only. This new size can be a increased size of already existing size, or this new size can be any reduced size of already existing size. Suppose if you have already allocated like this, that can be reallocated by using our realloc function. The name itself, it is saying reallocation. Got it, all of you? See, these are all the dynamic memory allocation functions that we have in our C programming language. Remember, what is the use of this dynamic memory allocation function is to work with your memory at the time of executing your program, at the time of runtime. Okay, so Malloc and calloc are used to allocate the memory, continuous memory allocations only, and free is used to free the memory whatever you have allocated, and realloc is used to reallocate the memory that has been already allocated. Right, all of you? I think you all are clear with this concept of dynamic memory allocation functions. So let us all meet in next lecture. Until then, thank you all of you.